I was just wondering about some issues regarding this automatic removal of parts, because when I am printing some large parts, they are either shrinking and deforming, or I have to use some additional materials on the bed that improve the force,
the adhesion.
But then when I apply those additional materials, it's really hard to to remove it. So how do you how do you deal with these issues?
So our printer, the exact reason that we have the automated removal mechanism is when we print, we make sure that there's not warping, the warping problem that you're talking about, and it sticks very strong. So the warping is an exact trade-off of how difficult it is to remove the part. And the harder you get it to stick, the less likely it's going to be to warp, but that also makes it more difficult to remove. Our automated removal mechanism is a nut and lead screw driven system, so it has mechanical advantage. It's designed to be able to remove parts that fill up our build volume. If we went and made a bigger printer, we'd have to re-engineer it so it was a little beefier for that bigger system. But you have to design, like anything, you have to design for a specific machine application. But in this case, there's no part that can be printed on our printer that can't be removed by our removal mechanism.
Big is the base plate?
It prints roughly 19 centimeters by 21 centimeters by, that's the base plate, and then it does 25 centimeters tall.
That's quite big.
Yeah, and we can remove parts for the entire thing. We have yet to face any single part that we can't remove.
Nice.
And we've done roughly 25,000 print jobs. So I'm pretty confident in that statement as an engineer.
That's cool.
Yeah.
What's the difference between this preview and the final G-code which is being generated?
Oh, so the preview isn't G-code based. That's why we're able to do everything so instantaneously. It's pre-sliced, right? The thing about the preview that's not being shown is if you actually have support material, we're not showing you the G-code of the support material. And that's what we talked about that we're working on, is rendering what the support material would look like. But that's a very, very difficult computational problem to do instantaneously. The key with our 3D print preview tool is it also works on a smartphone. If you have one of the newer models of an iPhone or Samsung, they have strong enough graphics cards that all of this in-browser rendering works on a smartphone. So you can do it all on mobile, but the problem becomes much more computationally intensive when you're trying to render additional things, because it makes it a bigger file and that makes it more difficult for your phone to actually process it. So going back to the presentation,